Okay. Let me briefly review what we saw in the last lecture. The essential idea that we introduced in the last lecture is we wanted to develop an understanding of how numbers are represented in computers. Because binary system, decimal system is very natural for us. We've grown up with it, but computers can represent only two states, 0 or 1, on or off, kind of a situation. So we developed a new system of representing the numbers, the natural numbers, the real numbers, etc., in the binary world. So we saw an introduction to what binary systems are, and a bit is essentially one position that can occupy two states, 0 or 1. Whereas in a decimal system, a bit would be one position that can occupy 0 to 9. And when we generalize that in an octal system, we will have 0 to 7, and in hexadecimal system, 0 to 15, for example. And so we saw how to generalize that conceptually, and then the difference between integers and floating points. And in floating point, we saw single precision versus double precision. That is, when you use 32-bit to represent a number, it's called a single precision. And in the decimal world, it turns out to be about 7 significant digits. But in the binary world, we assign of the 32, 22 bits to the mantissa, and the remaining, I think, 10 bits or something like that to the exponent. One question that I've had from students, I guess, few that have come to my office is, what do I need to remember? For example, do I need to remember what is the maximum integer number that can be represented in int 16 or int 32, which will be a huge number? I don't expect you to remember those things, but having understood that, I might ask you to calculate what it is. In an exam, you're not allowed to have a computer, but you're allowed to have a calculator. Okay? A calculator is allowed, and so you can do simple arithmetical operations with a calculator. There will be nothing more than that is required in terms of calculations. And you should be able to understand what that statement is. What would MATLAB do if I enter that? You should be able to understand that and figure that out. And I will show examples of those kinds of things. But of course, when you're solving problems in other courses like 2176, you will actually use the full-fledged language capabilities to write your own functions, your own programs, and solve algebraic equations, differential equations, etc. That will be the focus in 2176. So in this course, we are going to learn enough about computers, enough about MATLAB, and how MATLAB communicates with Excel and other programs, so that we can use that as an effective way of solving. Okay? So you should know the difference between integer representation, integer 8, integer 16, integer 32. What do we mean by that? 8 bits, 16 bits versus 32 bits. And then the single and the double floating point representation, you should understand that. So these are some of the commands that I've asked you to familiarize yourself with. And whenever I put a set like that, you should spend some time after the lecture to go into MATLAB and learn about those commands, what those commands mean, how do they work, what are their inputs, what are their outputs. You should know that, because we are building slowly vocabulary of MATLAB. And literally there are 10,000 functions like that. And probably what I know of MATLAB is less than 10% of it. Okay? And by the end of this course, if you learn 1% of it, you're doing very well. Okay? But what is more important is for you to learn. Okay, so if you know the concepts, then you can learn what the other functions that you might need. And whenever you're asking for help on a particular function, it gives you information about related functions. So that ability to learn on your own is an important thing that we are going to cultivate in this course. Okay, so many of these functions I try to build into the assignment. So similarly, the functions that we are going to see today, I would try to build it into the assignment that I've handed out today. And not all of them may be in the assignment. So you should make an effort to understand what these functions mean. You will be responsible for knowing this set of functions. If it is in the notes, you are responsible for knowing it, whether I have the time to talk about it or not. Okay? Because in the class, it is dynamic and I'm reacting to your questions. You're going slow sometimes, so I may not be able to cover everything that is in the notes. Okay? So you should be responsible for whatever is in the notes. So the decimal to bin to DEC, these are the functions that convert A function is a rule, and the rule takes certain inputs and produces certain outputs. The inputs are given in parentheses. There may be more than one input, and the outputs are given to the left of the equal sign. Those are the outputs produced by that function. So all these are functions like that. Okay. The one function that I want to focus a little bit on is the most general functions of this set. That is, we didn't talk about it last lecture, and I think it is important for you to know. That is DEC to base and base to DEC. What that does is it converts a decimal representation indicated by this input to any base. In binary, it converts to binary. Decimal to bin, this converts only to the binary string, binary to decimal. Similarly, this is hexadecimal to decimal, decimal to hexadecimal. But this is to any base. Okay, and what is that base? The base is a second argument. So if you have that, you don't really need decimal to bin and decimal to hex, etc., because you can identify what the base is. Okay, so I want to spend a little bit of time talking about these different other representations. We talked about decimal and we talked about binary. So through an example, I'm going to try to illustrate how we would represent in other bases. For example, if I have a decimal number, 675, the meaning of 675 in the decimal system is the position 6 is in the 100th place, okay, and the position 7 is in the 10th place, and the position 5 is in the 1 place, okay, and we add them up and we get 675. The basis here is 10 to the power. It is 10 to the power 0, 10 to the power 1, 10 to the power 2, etc. Not all of them may be present in a number, but that is the basis. In a similar way, in a binary system, the same number 675 in the binary system is represented in this way. And there was a question last time, how do I do that? How do I convert decimal into binary? If you have access to MATLAB, you can do that. In an exam, you should be able to do that for small enough numbers that you can do using the logic that we saw. That is, you have to find what is the 2 to the power, the largest number that can still divide 675 and leave a residue. Okay, and so it will turn out to be 2 to the power 9. Okay, so you can go to MATLAB and do this, or in your calculator in an exam, that's what you would do. 675 divided by 2 to the power 9. Okay, sorry, 675, let's subtract that. So that leaves 163. So then I will take 163 and find out what is the next largest power, 2 to the power, that I can divide that by. For example, if I say 163 divided by 2 to the power 8, that would be the next number. It's already less than 1. Okay, so I don't have enough number 2 to the power 8. So the 8th position would be 0. Okay, and that's what you will see. For example, if I flip it back, the 9th position is 1, but the 8th position is 0 because I don't have a placeholder for that. That number doesn't figure. So the next position is I need to check whether 2 to the power 7 could be 0 or 1. So I would go in there and divide this by 2 to the power 7, and I get 1.27. Okay, so I subtract that to find out what is the next number, and I have 35. So I need to find out, continue like this. This can be a rule. It's a repetitive rule, so you can actually write it into a function. Function, as I said, is a rule for calculation, and that's exactly what MATLAB does. Oops. Okay, so using that logic, I figure out the next one is 0, the next one is 1, the next one is 0, and 0, and 0, and 1, and 1. Okay, so that is for binary. Now, octal system uses a set of 8 positions. Instead of 2 or 10, it uses 8 positions. So the numbers that must appear in an octal system would be from 0, 1, 2, 3, 4, 5, 6, 7. Those are the 8 distinct symbols that we use to represent 8 different positions. So our base now becomes 8. 8 to the power 0, 8 to the power 1, 8 to the power 2, 8 to the power 3, etc. And we need to find these coefficients that multiply them. And these coefficients can be numbers from 0 to 7. Okay? So in an exam, I might say something like this. Okay? What was the function name? I forget. What is it? Decimal to base. So let's take that as an example. Okay, so I will give this statement: decimal to base 675, comma. Let me not do that. 679, comma 3. and ask you what would MATLAB do, what do you think it will do? What am I asking? What does that decimal to base function do? It takes the first number that you see here, 679, and tries to express it in base 3. The second position there indicates, second argument indicates constructed in base 3. Okay? So if I say put 2, it's going to be binary representation. Let's do that. So that's a binary representation of 679. Okay? And my question to you is, if I give me a base 3 representation, what should MATLAB give? Anybody? 0. The numbers should contain only 0, 1, and 2. Okay? Now I'm going to inverse this. So base 2 decimal. And I'm going to put, okay, let me just put some number here. Base 3. Oh. String base, yeah. Base 3. What should it do now? I'll give you an error message. Why? Because there is a 4 there. Okay? So this kind of a thing is what I would expect you in an exam. Okay? More questions will be of this type when you know that MATLAB, not remembering specific outputs. I'm not going to ask you to find this one, for example, unless the number is fairly small enough. Okay? Otherwise, you need to do this factorization with 3 to the power something repeatedly. Okay? But this thing, by looking at it, you should be able to tell, okay, this doesn't work because I understand what base 3 is, what the significant, the digits are that can be in base 3 representation. Okay? So, similarly, in octal representation, only 7 numbers can be there. Okay? 0 to 7. The symbols can be there. And that function that I showed you will give you the answer to that. Do you want to do that? Decimal to base 675. There. Okay? Now, hexadecimal. Hexadecimal uses a 16 base. That means it's going to have numbers that are 16 to the power 0, 16 to the power 1, 16 to the power 2, etc. But the symbols that are used to represent the 16 possible positions are designed, arbitrarily designed based on what we know. You can just design any other symbol that you want. But typically this set turns out to be from 0 to 9, 0, 1, all the way to 9. That gives you 10 positions. And then the first 6 letters of the alphabet, A, B, C, D, E, F. Now, if you look at, I don't know if anybody has played with networking, then something called the MAC address on the machine. Do you know what that is? The MAC address for the Ethernet card will consist of hexadecimal numbers. Okay, it's a 32-bit address. So you will have 2 numbers, hexadecimal numbers, a colon, and then the next 2 numbers, hexadecimal numbers. And that's where that comes from. Okay, to represent a 32-bit number in a unique way, they use the hexadecimal representation for MAC addresses. Okay, so that's all you need to know about number representation, that such representations exist, and these have been generalized. And in MATLAB, if you go and we talked about the decimal to bin, right, which takes as an input a decimal number and produces a binary number, right? So if I want to know how does that function do, that is, we'll see more about how to write functions later on. But a function is some specific name and some specific input arguments. Now, if you say type is a command that lists that particular function, okay? Decimal to bin. This is a function that MATLAB wrote for us using the logic that we talked about. That is 2 to the power maximum number, divide it, and then take the subtract, whatever is remaining, find the next digit, etc. This has to be done repeatedly, and that code is there. By the end of this course, I would expect you to be able to type out functions like this and be able to understand that. What is it saying? Okay, and most of it in this function are simple error checking procedures. The actual algorithm are the last two lines. Okay, so the actual algorithm is here. These two lines figure out the complete bit pattern for any decimal system, decimal number that you throw at it. So by the end of this course, you should be able to decipher and tell me, that will be in the exam, for example. Here is the code. What do you think it does? Okay, so you should be able to understand that. That's our goal. We want to be able to understand programs like this and be able to write programs like that, which we'll then use in 2176 to solve problems. Okay? All right. MATLAB itself, are there any questions so far? Yeah?
So does the bin won't you like after as hexadecimal?
No. Des to bin only converts decimal to binary. Des to hex converts only decimal to hexadecimal. Yeah. If you want to convert from hex to bin, unless you can write your own function, and that's a very good question. One way of answering that would be you write a two-line function. And the first line takes the hex and converts it into decimal. The second one takes the decimal and converts it into the binary. You can create your own functions like that. Do you understand what I mean? We will write such functions pretty soon. Once we saw this, remind me, when we write functions, we will write that particular function, okay, to show you how to do that. Any other questions? But right now, with the set of tools that we have seen, his question was, how do I convert from hex to bin? Okay, we have seen tools from decimal to bin, decimal to hex, and decimal to general base. So if you want to go to hex to bin, you convert hex to decimal and then decimal to bin in two-step process using the two functions, or you write your own function. Okay? Any other questions? Now, MATLAB is, I think you have already used it, so maybe this is kind of a unnecessary introduction, but when you open up a MATLAB, you will see a graphical user interface that looks like that. You should have some idea of all the windows, the desktop arrangement, okay? The most important thing is the command window that you see right in the middle. So this is where you interact. The concept that you have to understand is that MATLAB has something called a workspace. Workspace is a place where it remembers whatever numbers that you have defined, okay? And the workspace, in fact, is reflected in here. Okay, so there is a workspace window. So if I go to the MATLAB window and I interact, when I say interact, I give it a command. It interprets that command, executes it, and sends out the output. So if I say A is equal to 5, that is going to decode that. Okay, I have A, so A is trying to create a symbol maybe, and then the moment I see an equal sign, it says, okay, this is an assignment. Then what comes on the right-hand side is 5. So it simply says, take 5 and put it in a variable I'm going to call A and store it in the workspace. So immediately you will see in the workspace that variable A appearing there. And it also tells you that it is of class double. Okay, so we already talked about integer 4, integer 8, integer 16, single and double. So double precision is 16 bits in decimal and it is 64 bit long. Okay, that's a double precision number. Okay, and its actual value is 5. I could have also done, for example, in the command window, B is equal to 256 times 5. So what I'm doing on the right-hand side is doing an arithmetic operation and then saving the result in B. This will immediately create in the workspace that B is equal to the result, 1780. It doesn't remember the operation on the right-hand side. It carries it out and it stores. Only when you do an assignment, it updates the variables in the workspace. So this is called the workspace where all the variables that you create will be saved. Okay? So you can create arrays. MATLAB, in fact, stands for Matrix Laboratory. And so matrices are very natural. Arrays are very natural in MATLAB. So I could create, for example, an array. The way I would create an array would be to say A is equal to, and I open a square bracket. That's how I indicate array, starting of an array. And then I can put, say, 1, 2, 3, 4, 5. And so I'm saying that I'm creating an array. The variable name is A, and it is an array, and it has 5 numbers and columns and 1 row. If I want to create a second row, I would put a semicolon, that says go to the second row, and then 6, 7, 8, 9, 10. And then I close it. So this, when I hit enter, MATLAB is going to decode, interpret, and say, okay, A is an array, and the first row contains the numbers 1, 2, 3, 4, 5, and the second row contains 6, 7, 8, 9, 10. That's a way, one of the ways that I can enter arrays into that. So it immediately creates that array on the workspace, and they made it really very easy for us. So if you have created an array and you want to change, for example, the position number, the value 8 here to some other value, there are two ways of doing it. You can go there and double click on that, and it opens up an array editor. So it opens up a new window on the top, and it shows you there, and I can change that to 16 if I want. Okay, so the changed value of that matrix will be stored in your workspace. Now, if I come to the workspace and type A, I'm going to get with the new position 16 there. Okay, any questions on that? Yeah. You click on, let me close that and show you one more time. So this is the standard setup, and every variable that you create appears in the workspace here. So here you say capital A. You double click on that. Once you double click on that, it opens up the array editor for that particular variable. Okay? So suppose I do this. I can recall the previous lines using the up and down arrow. So I'm going to create a new vector B, and I'm going to call this int 8. Okay? What did I do? Every mistake that we make is an opportunity for us to learn. So I wanted to create an array called capital B, and I wanted to store the same array, but not as a double precision number, but as an integer 8 numbers. So I recall the previous line and put int 8 before that, but int 8 is a function. Function arguments must always be given in parentheses. Okay? So when I put a square bracket, it says create an array, and that array can be stored or echoed or passed on to another function. So the mistake that I made is I should have put a parenthesis there. Okay, now what happens is what you see in the square brackets is a double precision array. If you look at A, if you look at in the workspace, it is classified as a double precision. Okay, so I'm constructing a double precision array, but I'm passing it to a function called int 8, which is going to convert that into an integer 8 array. Okay, so these classes of functions, the variable names that you should be familiar with. So if I hit return, so if you look at A, what happened? I want you to see A and B I defined in the same way, right? And in A I have 1, 2, 3, 4, 5, and then 6, 7, 16, 9, 10. And, oh, I guess I have the same thing. In B I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let me do this. Instead of 8 in the place, I'm going to put 128. Okay, let me say 256. What do you think would happen now if I hit enter? Lead to an error. Take a guess. That's a very good way of figuring it out. This is in fact what I asked you to do. When you're doing the assignment, don't just blindly type and write it out, because that's not going to be a good preparation for the exam. Think about it, predict what would happen, because that shows that you understand it, and then try it out and see whether your prediction is right or wrong. So that's what we are doing here. Okay, so I'm taking an array which has numbers 1, 2, 3, 4, 5, and then 6, 7, and then 256, and 9 and 10. What is the largest number that I can represent in int 8? 128. So what would it do with 256? That's what you need to think about. In an exam, a question like this will be there. Okay? It doesn't have enough bits. When you are taking, what it does is it takes 256 and writes it in floating point 64-bit representation, internally converts it, the int 8 function converts it into 8 bits. So I have only 8 bits to represent. So the maximum number I can represent is only 127. So no matter what you put there, it will convert it to the maximum possible number that you can represent there. Do you understand that? Everybody? Okay? These are the type of things I would expect you to answer in an exam, where I will have just a statement like this and say, what would MATLAB do? Okay? A minus B. So this is an operation, an arithmetic operation between two arrays. When that happens, both arrays must have the same size. Because what does A minus B mean when you have two matrices? When you're subtracting one matrix from the other matrix, what does it mean? You're subtracting the corresponding elements from each one. Have you done linear algebra? Right? So, linear algebra course is essential to understand what MATLAB does, because MATLAB is a great tool. Did they use MATLAB in linear algebra? In many places, when they teach linear algebra, they use MATLAB simultaneously. They introduce how to implement the ideas that you have seen on the board. Okay? So what is the error message now? Integers can only be combined with integers of the same class. So what am I trying to do an operation between a double and an integer 8? So that doesn't work. Okay? There was an example in the assignment. Let me construct an example similar to that. I think that is A is equal to 23.4. So A is now a double, and B is equal to single 23.4. So what am I asking the function single to do? Take 23.4, which you by default always interpret it as a double precision number, 64 bits. But convert that into single, meaning use only 32 bits to represent that number 23.4. Certainly you can, 23.4 is small enough number that you can represent it in single or double. So what is the difference between A and B now? A is double and B is single. Now in the integer class, it did not even allow us to mix, right? But here, if I say A minus B, what is it going to do? Now the answer for that may not be known right now for you, but you need to play with it to understand it. Can anybody guess what it might do? Error is one possibility. Anybody else? Give a small number is another possibility. What is the third one? Right. Now explain this. Why is that small number there?
Because there were many digits, or there were many whatever from A. It's like 3 and then.
Right. So when it was constructing B in single precision using 32 bits, it had only 32-bit representation of that number 23.4. When it used in A, it had 64-bit. So there are 32 extra bits that were all filled with zeros. Okay? So it is accurate up to 16 digits. And now you're subtracting these two numbers, it has to fill up the remaining 32 bits. So what it does is it converts the single precision to double precision by taking the next 32 bits from whatever there was in that bit position in memory from the previous calculations. Okay? So that is junk. And it takes that and subtracts it. So it is not filling everything with 0, and so you get in the 8th position decimal place some errors coming from that remnant of whatever there was in the memory location. Okay? So you have to be careful when you are mixing different types of classes. That's one of the lessons that you need to learn. Now you might wonder, in fact someone asked me this question, I'm a chemical engineer, why should I know about these things? Computer scientists should know about it. Okay? But chemical engineers, the computers are there everywhere. If you're an engineer, you must know what a computer is, how it is used in a plant where the data of temperatures, pressures, flow rates, concentrations are coming from the plant to your computer all the time. They are logged in. And however it is logged in by the guy who produced the thermocouple, he has a program and it samples maybe 8 bits, maybe 16 bits, depending on the precision of the instrument. He's going to send the data in that format, and you need to be able to deal with it. Okay, so you should have some appreciation. You're not going to be creating operating systems, but you're going to be creating simulations. You're going to be using simulations of chemical processes. So you should have an idea of the sources of errors like that. Okay? So arrays are simply created in that particular fashion. Okay? So we talked about workspace window, command history window. Okay. So there is a window here that's called command history. All it does is keeps track of every command that you have ever entered since you started MATLAB. Why is it useful? It is useful because if you want to grab some command and re-execute it, you just highlight it and then drag it and drop it here. The command is there for you to edit. Up arrow, down arrow also gets you that. Another use of that is you can actually test with this and collect a set of commands and plug it into a script file or a function file. It's very useful for writing functions. But the command history is basically a history of what you have done. Okay? And then the current folder file, that's an important window too, because it shows you where you are in your tree structure of the directory, which directory is your current directory. You're working on assignment 1, you might want to create a directory for A1. Then you may create a directory called A2. Okay? So you want to know what the current directory is so that the functions, variables that are defined in there are available to you. Okay? Okay, so there are some simple commands like demos, help. Help is an important command because if you want help on any particular command, you just type help. Oops. Okay. Help decimal to bin, for example. You should know something about the function, then you can type the function name, and it gives you a very brief description, but it also tells you the related commands that are in there. Okay. Another way to find out useful functions is, if you look carefully here, there is an fx function of some variable x. So if you click on that, it opens up something called a browser window. So it will show you all the functions that are available in MATLAB. For example, if I want to go to, this is various tree structured directories, and I want to go, for example, to mathematics, linear algebra, or even arrays, basic information. So disk is a function. Okay, display is a function. Is column a function? Is empty a function? So you can click any of those functions and it will open up a help window. So another way of getting at the help, if you don't know the name of the function, but you know approximately what you want to do. I want to find matrix inverse, for example. What is the name of the function that will do matrix inverse? Okay, so let's go there and look at not basic information, but linear algebra, because you should know that inverse would typically appear in linear algebra. So there you have all the things: determinant, rank, linear equations, Cholesky factorization. There it is, inverse of a matrix. Okay. So if you know approximately what function you want to do, you can search for the function name through that process. Okay. And then the demos are very nice. There are some very nice graphical demonstrations of various ideas that you can play with. Who is a useful function in the days of only command line before graphical user interface came. Right now it's not particularly useful because what does it do? Let me just switch to MATLAB. Okay. If I type, for example, whos, it lists all the functions that are in the workspace, the variable names that I have created in this session. Okay, but they are always displayed for me in this window too, so I really don't need the whos command now because I have that displayed all the time. But it is available there. Okay, and similarly, you can clear. Okay, if you want to, for example, erase everything from your workspace, you just say clear, and all the variables that are defined on the workspace is gone. Okay, now if you type A, it doesn't know anything about A because it doesn't erased. Okay. So you should read through this to clear, for example, a single variable. You can use the format clear the variable name itself. Okay, and I think we talked about this. Yeah, we are talking about arrays. So let's do a lot of manipulations with arrays and learn how to deal with and work with arrays in MATLAB. That's what this whole lecture is going to be on. Okay, so if I want to create an array, there is a function called magic. Okay, what does it do? If you want to know what does it do, you can ask for help magic. Okay, it creates a magic square. Okay, so if I say A is equal to magic 5, it's going to create a 5 by 5 matrix with certain numbers. Now, why is it called a magical number? If you take the sum on any row or any column or any diagonal, it will always be the Same number. Okay. How do I show that? For example, I have A. So if I say sum A, sum is another function. Okay. What does that do? It simply sums along the column. Okay. So it prints out 65. For example, the sum of the first column is 65. The sum of the second column is 65. Sum of the third column is 65, etc. Okay. So if you want to sum along the rows, what would you do? That is, I want to sum 17 plus 24 plus 1 plus 8 plus 15. So you can say, okay, help sum, and see whether sum has an option for you to be able to do that. Okay. Sum x is the sum of elements of the vector x. If sum is a matrix, x is a row vector with the sum over each column. Okay. And that's all it does. So how would you create a sum over rows? In linear algebra, have you heard of something called a transpose of a matrix? What does transpose do? Right. So if I say in MATLAB, the syntax for that is A apostrophe. So you compare this carefully. Okay. So let me store this in a matrix called B. Okay. B is A transpose. Okay. So A and A transpose are the transposes of each other, right? So if I pass sum to B, what do you think would happen? It will still sum over the column, because sum sums over the column, but I've changed all the rows into my columns. Okay, so I still get 65. So the magic, one of the properties of the magic square is that whether you sum across rows or across columns, is going to be the same thing, even across the diagonal. So suppose I want to extract the diagonal. How do I do that? So there is a function called diag. Okay. So this is a fairly sophisticated function, and we will use this when you're doing, for example, separation processes, absorption, distillation column. We will need to construct something called a tri-diagonal matrix, and I will show you how to do that. So this is a very powerful function which allows you to construct diagonal matrices. So let's try to read that and understand what this help message tells. Okay. Diag v comma k. Okay, so it takes two input arguments, v and k. V is a vector, a row vector or a column vector. So what is the difference between a vector and a matrix? If I have C is equal to 1, 2, 3, 4, 5, I would call that a vector. Vector is nothing but a special form of a matrix. So there is a function called size. If I pass A, it gives me 5, 5. What does it mean? Can you guess? Number of rows and number of columns. Okay, so A is a 5 by 5 matrix, B is a 5 by 5 matrix. What would be C? 1, 5. Okay, so D is equal to C transpose. What would D be? A column vector, 5, 1. Okay, so if I pass size D, it's going to be 5, 1. If I'm going fast, tell me. You don't have to write it down. As I said, the notes is there. The examples that I'm using here are not necessarily exactly the ones in the notes. Okay. When I write the notes, I figure out some examples to illustrate the point. But I'm talking about the same area. Okay. But since I'm just making up these numbers, it will be slightly different. But you can also go back and listen to it if you want. How many of you use the recorded lectures? How many of you have used? Not many, so it's not really worth it, all the effort. This is where I think you will find it useful if you focus attention on the class instead of trying to write down, because these are very difficult to write down what I'm doing there. Okay, pay attention, understand it, and you can always play it back, and there is a printed version of it as well, exploring the same ideas. Okay, and it is important to get these ideas and know what the functions are. So at the end of this lecture, you should know what these various functions that we talked about, the size, the magic, the transpose, etc. Okay? Any questions? So all these variables A, B, C, D are by default double. Okay? But you can create any other class, integer 8, integer 16, by simply passing them. So integer 32, A, we'll take A and convert it into the integer 32 class. This will use only 32 bits for each number. Okay? And of course, you cannot mix this result with another class. Okay. Yeah, the other thing about assigning, changing the single variable. For example, in this matrix A, which is 5 by 5 matrix, if I want to address a particular element, for example, A 3, 3. So look at the way that I've used. A is a variable name, but it is an array. Array means it has subscripts. Okay, the subscripts are indicated by the 3, 3. So to address or to print out or pull out that particular number, right now I'm saying give me the number in the third row in the third column. So what would that number be? 13. Okay. So if I want to do this, what do you think? Well, I should tell you first about this. What does what does a colon operator do in MATLAB? Okay. The colon operator, just like plus operator has two numbers on both sides, it adds them. A divide operator has two numbers on both sides, it divides one by the other. So similarly, there are binary operators and unary operators. Single operator operates on one number, binary operates on two sets. So here, the operator is colon, and the operand is 3 and 5. So MATLAB would interpret that as 3 a number, and then an operator colon, and a number 5. So it says, okay, he wants me to produce a number from 3 to 5. So it produces 3, 4, 5. Okay, so if I do 3 to 15, it does it 3 to 15. So if I want to produce a number from 3 to 15 in steps of 2, not by 1, what do you think I would do? That's what I need to do. So start, increment, end. Okay, that's a very powerful construct. So it allows you to build vectors very easily in MATLAB. This is applicable for any class. For example, I could do it with 0 to 0.2 to 1. What would this do? 0 to 1 in steps of 0.2. So it's going to produce a vector which is 0, 0.2, 0.4, 0.6, 0.81. Okay, so that colon operator is very powerful in creating vectors. Okay, and then it can be used intelligently in a number of situations, in for loops, and we'll see that later on. But array addressing, we want to now look at array addressing. So if I want to address 3 to 5, so what do you think this will produce? Well, let me print out A for you so that you know what A is. And then I'm saying A 4, 3 to 5. If I enter that, what should MATLAB print out? What am I asking MATLAB to do? I'm asking go and look in your workspace where the variable A is defined. Go to the 4th row. First index is 4. And then comma. Comma says, okay, what is the column range? Column range says go to 3rd, 4th, and 5th column. Print out that number. So what would that number be? 19, 21, and 3. Okay. So this idea you can use in any way that you want. For example, I could say 2 to 4, 4. So what would this do? 4. Exactly. From 2nd, 3rd, and 4th row, but column 4. Column 4 is this, so it's going to print out 14, 20, and 21. Okay, and it preserves the same structure. If you pull out a column, it prints it as a column, like in the second example. If you pull it out as a row, it prints out as a row. Okay, so you can address not only individual elements in an array, but a group of elements. Okay. What do you think this would do? These are the things will be in the quiz, and you need to understand. You don't need to remember anything. I'll give you the matrix and say, if I enter this, what would MATLAB do? One to 5, but in steps of 2. So it's going to pick 1, 3, and 5 on the 4th column. So it will be 8, 20, and 2. Okay, so you see the power. Very quickly, you can see that you can construct huge arrays and you can address individual sections of the huge arrays, and you can do arithmetic operations with huge arrays. Okay? Any questions? Okay, so we talked about, now let's talk about replacing the values. Okay, so we have created an array. So we've seen how to extract numbers out of that array, specific elements or groups of elements. Suppose I want to replace this element that I see, 8, 20, and 2, with 16, 40, and 4. How would I do that? Maybe it's a good exercise for you. Take 2 minutes, write out the function that you think will do the job I'm asking you to do. The job you want to do is take that matrix A. In the fourth column, the first, third, and fifth numbers must be replaced by what they have, 8, 20, and 2. I want it replaced by 16, 40, and 4. What piece of command will do that? Now what you're doing is you're not only trying to understand given command, but how to put together a command by yourself. And that will be part of an exam type. Do you understand the question? How many of you don't understand my question? I want to replace, this is not going to get recorded, I want to replace these numbers, 8, 22 by 16, 40, and 4 with one command. How can I do that? How can I replace 8, 20, and 2 by 16, 40, and 4? So I have to address, on the left-hand side, I have to address those elements, which is what this command does. A, parenthesis, 1, colon, 2, colon, 5. It says 1, 3, and 5 on column 4. On the right-hand side, I need to put 16, semicolon, 40, semicolon, 4. Why did I put semicolon? In the next row. So every bit that we see, we saw how to create the next row by putting a semicolon, right? You need to remember that and use that. Okay? There you have. So if I didn't put semicolon, what would happen? That would be part of the question as well. If I give you this, what do you think would happen? It works. It just takes that vector and plugs it into that. But if I had this, what would it do? Now you're saying I have 3 positions I have identified that I want to replace, but I'm giving you 4 numbers. They don't match, right? I cannot take these 4 numbers and put it into these 3 positions, so it should give me an error. Okay? Those are the kinds of questions you can expect in your first midterm exam. Okay? On arrays, and then whatever we see in the next lecture as well. Okay? Question? Okay, we already saw about size. So, yeah, the colon operator is actually very powerful. Can go backwards too. For example, I could do this. 5 colon minus 1 colon 1. What do you think that would do? Let me get rid of this. What would that print? 5 to 1 in reverse order. So you can see that 4, 21, 40, 16, 15. Okay? So once you understand this idea, it can be used in very powerful ways to write fairly complicated programs. You can concatenate 2 matrices. What does that mean? Okay? I'm not going to have time to finish all of them, but let me see. I created an A 5 by 5 matrix, and I have B another 5 by 5 matrix, right? So if I say C is equal to A comma B, what I mean is take A and concatenate, attach to it the matrix B. Okay? So I get a new matrix B that is 5 by 10. If I put a semicolon, what do you think will happen? Same thing, but which way? The 5 will go at the bottom. A and B were attached from side by side because it is row concatenation. Okay, so when I do this, it goes below that. Okay, so the same idea of a semicolon starting a new row, even if it is a block matrix, this would happen. This will attach. Suppose the dimensions are not consistent. Let me try to do this. A, comma, D. Sorry, A comma. D has 5 rows, A has 5 rows, so it can attach. But C has 10. Yeah, let's put C there. Okay, so that will produce an error because A is a 5 by 5 matrix, C is a 10 by 5 matrix. 5 rows and then 10 rows cannot attach. Okay, so when you are concatenating matrices like that, there must be some compatibility with that. Okay. We talked about the colon operator. Yeah, the other important thing is to understand that the matrices are actually internally represented by just one index. For example, A is 5 by 5 matrix here, but if I say A10, you might think that it is wrong because it's not a vector, but it's a matrix. But there is something called a row-wise major ordering. So A10 would actually mean it will count as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it will give you 18. That is, it counts from column wise. So you count up to 10. These are numbered as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So you can address this element either by saying A53 or A15. Both of them will give you the same number. So let me just show you that. Okay. So A10 is 18, the same as A5, 2. 2, 3, 5, 2. Yeah, 18. Okay. So there are two ways of addressing the array. One is using the subscripts, the other one is using counting along down the column in one continuous fashion. Okay. I think we're almost out of time. I want you to complete the rest of this chapter. And if there are important things in there that I couldn't cover, I think I need to talk, I will talk in the next lab. Otherwise, I will move on to the next topic. So you should be able to be responsible for whatever is in this notes. Okay? Yeah.